All right, so we'll continue with the like how you get your Ki for the competitive inhibition. So there are two ways you can get your Ki. So you can plot graph, you can plot what we call secondary plot, or you can use the formula method. So for the formula method, that one is very easy. Now, if you notice, for this graph now, everything here is showing competitive inhibition. Is that also because they are sorry, everything here is showing non-competitive inhibition. Is that also because they are meeting at the same km? All right. Now, but their Vmass differs. For those that person asking me how do we get the Vmass, so this is how you get the Vmass. The number it is touching here, this number is touching here, so this number 1 over all over that number is your Vmax. You understand? So what is the number it's touching here? Here is 2.2, 2.4, 2.6, 2.8, 3, 3.2. So it is touching 3.2. 1 all over 3.2 is your Vmax. So if I'm to do that now, we'll get what? 1 divided by 3.2, that is 0.31. 0.3125. This is my Vmax, okay? This is my Vmax now. Are you getting my point? So what is the Vmax for this one? This one Vmax. All of them, they're having different Vmax. This one Vmax now will be what? Here is 4. Here is 4.2, 4.4, 4.6. So 1 divided by 4.6. Are you getting my point? So this one will not be your Vmax for this other one. 0.217. Okay, so that's how you get your Vmax. While for your Km, the number it is touching here, 1 divided by that number is your Km. So for this case, now here is 0.4. So here will be 0.42. Is that not so? 0.42, 0.44. So here will not, the Km now is now 1 divided by 0.44. 2.27 is our Km. You understand? So here's the inverse of the number it is touching. For the y-axis, the inverse of the number it is touching here is your Vmax. For the x-axis, the inverse of the number it is touching here is your what? Km. Okay, so let's just use the calculation method to get our competitive inhibition. Now this is the formula you have to use. Ki is equals to what? The inhibitor concentration all over Vmax divided by what? V apparent minus 1. Let me do it in a fresh page. I think I should do it on a fresh page. Okay, let me just cancel this. See something here. We say what? Our Ki. Hope you know all of them will have their own Ki. Ki for 1, Ki for 2, Ki for 3, because there are 3 inhibitors. Look at it. 3 inhibitors. 1, 2, 3. I get my point. So each of them will have their own Ki. I get my point. Alright. So Ki for 1. Let me take Ki for the first one now. It's equals to waiting. It's equals to okay. It's equals to what? The inhibitor concentration all over the original Vmax divided by the new Vmax, which is the Vmax apparent, minus 1. So how do I remember this thing now? Just know that the Vmax or the original Vmax divided by the new Vmax for that one you want to solve for, then minus 1, then divided by the concentration. So let's do this one now. So Ki for the first one now. Look at it. Look. Are you getting it? All right. Look at this now. What is the inhibition for the first one? The inhibition for the first one. Where is it? Where do I write that thing that time? Okay. I think this is it now. Yes. Look at it. The inhibition for the first one is having a concentration of what? 0.5, right? So just put out 0.5 there. So our I for the first one, let me break out the figures. Our I for the first one is waiting 0.5. How about our original Vmax? Our original Vmax, which is the one that was not inhibited at all. That one is what? That is this one, Abi. This particular point here. So what are you going to do? You will say 1 divided by the number here, of which we said the number here is 3.2. So 1 divided by 3.2 is what? 1 divided by 3.2, we have a 0.31. Let me put it like that. So our Vmax is 0.31. How about our V apparent? This V apparent is the new Vmax for the one you want to calculate, which is this one for this our I1 inhibitor 1. So this is it, Abi. This is a 4.2, 4.4, 4.6. So 1 divided by 4.6. 1 divided by 4.6 will give us what? 0.22. Okay? Are you getting my point? All right. So what do I do now? Divide. So look at it now. Ki is equals to the inhibitor concentration all over Vmax real all over the Vmax apparent minus 1. So the Vmax, the original Vmax divided by the new Vmax will be what? 0.31 divided by 0.22. Abi? That is 1.4. Then minus it from 1. So let me just do it there. Equals to I over 1.4 minus 1. 1.4 minus 1 is equals to what? 0.4. So we have it. Our I, what's our I? Our I is what? 0.5, Abi. So we have 0.5 divided by 0.4. So what do we have? 0.5 divided by 0.4. I have 1.25. So my Ki now is 1.25 for the first one. For the first one, my Ki is waiting 1.25. How about for the second one? For the second one now, you do the same thing. So your Ki for the second one, again, you say Ki for the second one, second inhibition will be what now? Use the same formula. The concentration of the inhibitor all over what? The Vmax, the original Vmax, all over the Vmax apparent for that one, Abi, minus waiting 1. Is that also minus 1, minus 1? Alright. What's the concentration for the other one? Here is 1, Abi. Where is it? Where is it? Let's see. Let's see this. Okay, this is it now. Is 1. For the second one is 1. Okay. So my I for the second one is what? 1. 1. What about my Vmax? My original Vmax is constant, Abi. What do we get? The original Vmax 0.31. Is that also? So 0.31. How about the apparent Vmax for this one we want to solve for? Let's look at it on the graph. This time around, we're solving for what? What are we solving for? We're solving for I2, right? So for I2, the apparent Vmax is close to about 6. So there is 4.2, 4.4, 4.6, 4.8, 5, 5.2, 5.4, 5.6, 5.8. So 1 divided by 5.8, 1 divided by 5.8 will give us what? 0.17, 0.17. So our apparent Vmax for the other one is waiting 0.17. Is that also? So what do we now do now? Use the formula Ki2 is equals to waiting. The inhibition, this thing there is what? Where's the inhibition? The inhibition concentration is 1, Abi, all over. Our Vmax real is 0.31 divided by this one, 0.17 minus 1, Abi. So what do we now do now? We do 0.31 minus 0.17. Sorry, 0.31 divided by 0.17. Then minus it from 1, minus 1. We get 0.8. So we have 1 all over 0.82. 1 divided by 0.82. So we have something like 1.22 as our second Ki. You understand? Again, you do for the third Ki. So Ki for the third one. I get my point. Again, the formula is what? Inhibition concentration all over what? All over Vmax over Vmax apparent, Abi, minus 1. Okay? Vmax. This is our Vmax is constant. And also, what's our Vmax? Our Vmax was 0.31. Our Vmax apparent is what? Where's the third? Okay, here's this now. This one. Okay, this one is just touching 8 here. So 1 divided by 8. 1 divided by 8 is what? 0.125. 0.125. So 0.125. Alright, our concentration of the inhibitor at that point is what? Where is it? Can you check the question? There is a 2, right? It's 2. So I'll put 2 here. Okay, so what do we now do? We use the formula Ki for the third one is equals to what? Under inhibition, it's equals to what? I all over what? Vmax. Our Vmax there is waiting 0.31 over 0.125 minus 1. So we have 0.31 divided by 0.125 minus it from 1. We have 1.8. So we have 2 divided by 1.48. That is what? 2 divided by 1.48. That is 1.35 is the third Ki. Do you understand? 1.35 is the third Ki. Now this formula I'm using is only for competitive inhibition. Competitive. If you notice that the inhibition for that one is non-competitive, this is the formula you use. Okay,